Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Inverted Killer by Nurgle's Gift. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Cages sum to the total given in the cage corner. Ah, okay. The highest digit in each cage is inverted. So that is 9 counts as -9, 8 counts as -8, etc. And digits cannot repeat within cages. Okay, so this is normal killer cage rules, except the highest digit is always the negative version of it. So, for an example, this could be 9, 6, and 3, right? Because the highest digit is the negative digit, is always a negative digit. So the highest one would be 9. So that would be -9, and you add it to the other digits that are in the cage, I can't speak, which would be 6 and 3. So therefore, you know that -9 plus 6 and 3 adds up to 0. So therefore, this cage is satisfied because the 9 would be a negative again, and then added to 6 and 3, that creates a 0. And those are all the rules. Pretty cool, actually. I love killer cages, and this is an interesting variation on it. So I'm looking forward to this. Anyways, if you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, the first thing I see is the -8 cage, in which the only way you can have a -8 is if you have 9 as the largest digit, which is -9, and a 1 with it. So this specifically has to be 1 and 9. Therefore, what can the other cages be? I'm not really sure. -6. Well, you could have 2 and 8. You could have, so -6 can be 3 and 9 for 2 digits, can be 3 and 9, 2 and 8, or 1 and 7 here, right? So this is 1, 7, 2, 8, or 3, 9. This is also 1, 2, 3, 7, 8, and 9. 1, 2, 3, 7, 8, and 9. These have to be different sets. So it could be, if this is 1, 7, this can no longer be 1, 7, obviously. What else do we know? These digits have to be... Oh. 3 digits to make a -5. 9, 1, and 2. So this specifically has to be either 9, 1, 3, because the 9 would be negative, and then you have 1 and 3, which would be -5, or it's 8, 1, 2. Either way, there has to be a 1 in this cage. So it's either, again, 1, 3, and 9, or 1, 2, and 8. Because 9, 2, and 3 doesn't work because that's -4. So the 1 either way has to be here. Hmm. So that's the -6s, the -6s, the -5. -5 can be a lot, right? It could be 9 and 4, 8 and 3, 7 and 2, and 6 and 1. Okay. That's not too helpful there. Yeah, I'm not really sure what I'm looking for here, to be blunt. It's just like, oh, well, it could be this, it could be that, right? This is the only one we know. It's 1 and 9. 1 has to be here. We don't know about this. Hmm. -4 could be, it can only be, okay, so -4, what can -4 be? It could be 8 and 4. It can be 3 and 7, 2 and 6 here. Okay. Hmm. Well, one thing is none of these can be 5. So either 5 is here. Hmm. I'm not sure if that's the best approach here. Maybe let's go attack the -5 here. The -5 can be 9 with 4, 8 with 3, 7 with 6, and 7 with 6, not 7 with 6, 7 with 2, and 6 with 1. Hmm. Hmm. That's pretty broad. The 4, the -4, could be a lot of things actually. 9 and 5 is there too. 5 and 1. Huh. Um, we have a -2 and a -3 here also. Hmm. Okay. Hmm. Hmm. This doesn't really actually fit Killer Cages. This is definitely something completely different from Killer Cages because a lot of the things that I was looking for don't seem to give you very much information. Hmm. Okay. One thing we do know about this is that 2 of the digits equals 1 of them. So this must be 2 times something. I'm not sure if that helps any. Oh, that's interesting. Okay. Yeah, that actually is something that we can maybe use. The difference between this is 2. The difference between this is 4. The difference between this is 8. So either you'll have 2 odds or 2 evens in each of these cages, which would mean all of these are even. Now, the difference between this is an odd difference. So therefore, you know then you have an odd and even number here. So these are essentially even, right? Because this is either 2, 6, 3, 7, or 4, 8, if you add up the digits. So this would be even, this is even, this is even, this is odd. To add up to 45, which is an odd number, you need one odd and multiple evens. So therefore, this is an even number. Which means this can't be 5 either. That's interesting. Now, what about this one? This is even, and this is odd, and this is odd difference. So therefore, there's one even and one odd, one even, one odd. These are two odds or two evens, and this is two odds or two evens, which is an even number. So this is an even number, this is an even number. This adds up to an odd number, this adds up to an odd number. So that would therefore make this completely an even number. So this has to be an odd number. So it's 1, 5, 7, or 9. Well, since both of these are odd, if you subtract a large odd from two odds, yeah, how would this work? If you had 1 and 3, this would have to be 7. If this is 5 and 3, to have a difference of -3, that wouldn't work. So it could be 1, 3, 7 here. This could be 9 and 3, but then this would have to be 3 again, so that doesn't work. So this cannot be 5. So this is 1 and 7 specifically. And if this is 7, this is 3, this would have to be 1. But this can't be 1. So this must be 7, and this is 1. Because 7 would be negative, plus 1 and 3 would be -3. So this cannot be 1 and 7 here. This can't be 1 and 7 here. This can't be 1 and 6 here. Okay, so this is either 2, 8, or 3, 9 here. If this were 3, 8, that would eliminate all possibilities for that cell. So this cannot be 3, 8. So we know this difference is 2, 9, 2, 8, or 3, 9. This is 2, 7, or 4, 9. So 2 and 9 cannot be in any of the remaining cells in this box. So there's no 2 or 9. It could be 3, 4, 5, 6, 7, 8. And this can't be 3 specifically. So 3 could not be with 4, but that's fine. If similarly, what can this not be? I guess it could be any of them. These are fine. This can't be 1, that's fine. Do we have any other combinations like that? This is -2, this is -5, and this is oh. We have -2 here. This is 0. So this is an even number because the largest number adds up to the smaller two numbers. So that's 2 times something. I think -2 also is a even number for the 3 of them, right? So let's use an example. Say you had 9 with 2 and 5, right? 2 and 5 would add up to an odd, right? So you have an odd number plus an odd number, or odd number subtracting an odd number, you would give you a -2, an even number. You have an even number subtracting an even number, you would have also -2. So this is also adds up to an even number, and this must also be an even number, right? Because it's either 9, 5, which are both odd, which adds up to an even number, 5 plus 9. 8, 4, which is both even numbers, which adds up to an even number. 7, 3, 6, 2, 5, 1, all adds up to even numbers. So these are all even numbers, which means this must be odd. So this must be 3, 5, 7, or 9. We're not sure which. What about this? So similarly, could we do something like this? Maybe. This is 0. Again, this is even. This is even. This is even. This is odd. So this one has to be an odd. We have even, even, even. And this is even. So everything's even except for this, which is odd. Which means this has to be an odd number because 90 is an even number. And if you subtract out 90 for these, then that would mean this would have to be an odd number because we have all evens except for one odd, which forces this total sum to be odd. So therefore this is odd. This is 1, 3, 5, 7, 9. And then we could do something along the lines of here, right? So this would add up to 135 normally, which is an odd number. We know this is odd again. So this is odd. This is odd. So that makes an even by with its combined. This is even, and this is even. So this must be an odd number. So it's also 1, 3, 5, 7, 9, right? We have an odd plus an odd, even plus an even. So this must be right, because essentially, if you think about it, these inversions, if taking the inversion of the largest number, that to get its normal, like Sudoku sum, if you think about it, it's 2 times the largest number, right? So that's so if you start with an even number and you add 2 times the largest number, you're always going to get another even number. And if you get an odd number and you add 2 times a largest number, it'll always be an odd number. So that's why you can use these odd and even references in this inverted killers, right? So this is okay. This is odd, which forms an even. And this is even, and this is even. So all of this is even. Subtracting out 45, which is an odd number, means this has to be an odd number. So this is 5, 7, or 9. And we can keep doing that, right? This is odd. This is odd. These are even. So therefore, this is an even number here, which means this has to be, and this is an odd, so therefore this is all an odd number. Subtract out an odd number, this must be 2, 4, 6, and 8 because it's an even number there. Okay. I'm not sure how useful this is, but I mean, at least it gives us something. This is an even number. If this were 3 and 9, that's actually interesting, right? Well, okay, that's interesting. If this is 2 and 8, that means that eliminates 2, 6, and 4, 8. So this would have to be 3, 7. So then this would have to be 1 and 9, if that's the case. So if this is 2, 8, this would be 3 and 7, definitely. If this is 3 and 9, Hmm. That's not helpful. This is odd, which means this must have an odd and an even number. Right. To balance it out. Yeah. Um, hmm. So 5 has to be one of these. So 5 can either be with 2 or 8 here, or 5 can be with 3 or 7 here. But we don't know which one's which, right? Um, hmm. Okay. One of these is even and one of these is odd. That's not helpful though. Okay. If this is 2, 8, this has to be 3, 7. So, or this is 3, 9, right? So if this is 2, 8, this is 3, 7 always, right? Because it can't be 2, 6 and it can't be 4, 8 anymore. So this would have to be 3, 7. So there cannot be a 3 in the rest of the column. So this cannot be 3. So if this is 1, 3, and 9, it has to be 3 here. So this is not 9. If this is 3, 9, we know this is 1, 2, and 8 then. Hmm. This can't be 9, and this can't be 9. This can never be 9, 8, because that would eliminate all possibilities for this cage. So if this is not 9, this has to be 9, which would mean it would be 7 and 9. So this cannot be 9. If this is 9, that would have to be 8, but that would eliminate all possibilities for this cage. So either this is 1, 3, 9, or this has to be 9, 7. So those are the possibilities there. That's interesting then, because if that's the case, so again, if this is 3, 9, that would mean this is 1, 2, and 8. So therefore, this would have to be 7 if that's the case. Which would make that 5. The 5 would have to be with another odd number to add up to an even number, or to basically cancel each other out. So it would be 5, 1 to add up to 6, and it cannot be 5, 9. I guess it could be 5, 9 to add up to 4. Interesting. So either this is 5, in which case it would have to be 5. So either this is 5, which means it would have to be with 1 or 9. And this would be then equivalent of a 4 or a 6. Is that right? Right. If it's 5 and 9, this would be 4. If this is 5 and 1, this would have to be 6. Or it could be 4. So this is 5, 1 with 4 or 6. So if this is 5, this has to be 1, 9 with 4 or 6. If this is 5, it could be with 3 or 7. It would have to be with 7, though. Right? Because if it's with 3, the problem is... Well, it could be 3. Okay, yeah. The problem with this being 5 is that there's no other place for the 9, right? So this has to be 3, 1, and 9 then for that to be the case. So this would have to be 7 either way. Interesting. So this could be 139, and then this could be an even number, right? That's possible. Well, if it's 319, so this is 3, this is 1 and 9. This then has to be 2 and 8. Which means this is 3 and 7. Ah, and then these cannot be all evens then, right? Because if this is 319, this cannot be all evens here. Because this would be 2 and 8, and there would be 3 other unique digits, which cannot be 2 and 8, which would all have to be even, which is not allowed, right? Because that's only 4 and 6. So this would have to be odd. And cannot be, maybe it's 1 and 9. Well, 1 and 9 is here, right? So if this is 319, this has to be in 2 and 8 here, which forces this to be 3, 7. This cannot be 3 evens. So I guess this could be 6 and 8. This would be 5, essentially, because this could not be 5. Because, well, this would have to be odd. And we already have 1 and 9 removed, 3 and 7 removed, so this is 5 only. It could be 5, 9 with 4, or 5, 1 with 4 or 6. But either way, this would be 4 or 6. And then this would have to be 4 or 6. So 4 or 6 could be with another 4 or 6 or 2 or 8. We're not sure. But we do know that that's if this is 139. If this is 128, this cannot be 2 and 8. This must be 3 and 9. And this has to be 7 and 9. So this would specifically be 7, and this would be 9. This would then have to be 5. Okay, so this can never be 5 is essentially the point, right? If we tried to make this 5, this would have to be 3, 1, and 9. But then this would have to be 2 and 8 then. And if this is 2 and 8, this has to be 3, 7. And again, this cage would see 2 and 8, and it would have to have either 2 odds and 1 even, or 3 evens, which is not allowed, because it would have to be 3 unique evens without a 2 and 8. So that wouldn't work. So this would have to be odd. 3 and 7 would be here, 1 and 9 would be here. Therefore, this is always 5. Because if this is 1, 2, 8, this has to be 7 and 9, because 9 cannot be here with 8, and 9 can't be here. So this can never be 5, which means this is always a 5, and this is always odd. So therefore, these are 2 evens. So this is 2, 4, 6, and 8. We're not sure which ones. We have a 1 or 9 here somewhere. This is 5. So 5 can only be with 1 or 9, which means this is, if it's 9, this is 5 and this is 4. If this is 1, this is 5 and this could be 4 or 6. We're not sure. Okay. What are the possibilities then? This could be 7, and it could be 7 with 6 or 8. Or this is 7, 9. It can never be with, well, this could be 7 and this could be 5, right? Possibly. Interesting. These are two odds. This is even. These could be all even, potentially, right? 2, 4, and 8 works. It would specifically have to be 2, 4, and 8. If it's all evens. If it's all odd, or sorry, 2 odds and 1 even. Hmm. Hmm. Huh. Yeah, this definitely taxes a totally different logic behind besides killer. It not completely, but it's still quite a bit different from killer. 1 of 3 or 5 is here. This cannot be 3 and 5. But this could be 5 and 6. This could be 3 and 4. Hmm. Okay. So this is an odd. This is an even. This is even. These are odd, odd, and odd. Oh, this has to be 1 here. No, it could be 2 and... No, it can never be 2 and 8. If this is 2 and 8, this is 3 and 9. And yeah, because there's no other place for 1, right? 1 can't be here. 1 can't be here anymore because 1 and 7's are removed, and 1 can't be any of these. Oh, wait. Is that actually the case, though? Do we actually have a guarantee this is a 5? This could actually be a 1, right? No, because this can't be, yeah. If we tried making this 3 and 9, say, right? You can't make this 2, 8. If this is 2, 8, this becomes 3, 9. This can no longer have 2, a 6, 3, 7, or 4, 8, so those are all removed. So that doesn't work for that, or if it's 2, 8. And if we tried 1, 3, 9, similarly, so if we try 3, 9 by itself, this would be 2, 8, and then we'd have the same problem, right? This can't have 3, 7, you can't have 2, 6, and you can't have 4, 8. So 1 cannot be here. 1 has to be here. Therefore, 1 has to be one of these 3 cells. Interesting. So what if this is 7 and 9? Right, so if this is 1, 2, 8. This is 7 and 9. That forces this to be 5. But the problem is, I don't think that works. Right? Oh, we could have a larger one. You can't have 1, 2, and 8. No 7 and 9. So you have 3, 4, 5, and 6. But that doesn't work. 5 with what? 3 and 4? 3 and 6? Yeah, that just doesn't work. Okay, so this cannot be 1, 2, 8. If we try again, we tried 1, 2, 8 here. 9 cannot be here because it would have to be with 8, but we already have an 8. So this would have to be 9 with 7. But that would eliminate 7 and 9 here, so this would be 5, and the remaining digits would have to be 3, 4, 5, and 6, which just doesn't work with any combination, right? 6 would have to be 5 and 1. 4 and 1 would have to be with 5, and then 5 would have to be with 2. So this cannot be 1, 2, and 8. It has to be 3, 1, and 9. So this is 3, 1, 9, which means this cannot be 3 and 9. It's 2 and 8. This 2 and 8 eliminates 2. This can't be 9 anymore. This 2 and 8 eliminates 2 and 8 here because of the 2, 8 pair. And this can't be 2, 6 or 4, 8. So this must be 3 and 7. And it eliminates 2, 8 here. So this cannot be 7. It could be 5 here. Or this could be 4 and 6. Again, this cannot. This has to be 2 evens here, which means this has to be 5 with a 1 or a 9. So this is 3 and 7. This is 5. This is 4 and 6. So 5 cannot be here because 5 would have to be with 3 or 7. This can't be 7. This has to be 4 and 6 with 2, 4, 6, or 8 there. This is 3 with 1 and 9. So 3 cannot be here. Where is the 3? It has to be here. So this is 3. One of these is 1. We have a 4 or 6, and we have a 1 or 9 here. Well, 5 can't be here because it would have to be with 3 and 7 specifically to be here. So 5 has to be here. So this has to be 5 with 2 or 8. So we know 5 is here. This has to be 2, 4, 6, and 8 as possibilities. But if this is 2 and 4, that would eliminate all possibilities for this cage, right? It would have to be 2, 7, or 4, 9, but it can't be either if this is 2, 4. So this can never have a 2, because if this is 2, it would have to have a 4 with it. So this can never be 2. Sorry, this has to be 2. So this is 5 and 2. This can never be 2. Therefore, we now have a 4, 6, 8 triplet in row 7, which eliminates 4, 6, and 8 from the rest of the row. So this cannot be 4, so this can't be 9. This is then 2 and 7, which eliminates 2 and 7 from the rest of the box, and the row too, actually. So this can't be 7. This has to be 3, 5, and 9. This cannot be 2 and 8 anymore, so this is 3 and 9. So we don't have a 3 or 7 anymore. This can't be 3 or 7. Well, Where's the 8? 8 cannot be with 4, 5, or 6 in this -1, so 8 has to be here with the 6. So this is 6, 8. This has to be 4, 5. We have a 4, 5, 4, 5 pair, which eliminates 4 and 5 from the rest of the row, so this must be 2, which makes this a 5. What else do we have here? If 6 is the largest, it has to be with 1 and 3. Okay. What's the remaining digit here? We have a 5, we have a quintuplet, 1, 4, 6, 8, and 9 quintuplet here, which means we have only a 7 remaining. 7 can be with 6 or 8 to add up to get a -1. We now have a 4, 6, 8 triplet actually in column 7, which eliminates 4 and 6 and 8 from the rest of the column, so this must be 2 and 5. 2 and 5 add up to 7, and that's it. So therefore, and it cannot be 3, so this would have to be 7, which means this can't be 7. This can't be 7. Okay. This has -4 between them. We couldn't have a 3 anyways. One of these is a 3. This cannot be 2 and 8 anymore because we have a 2, 8 here, and that would eliminate all possibilities for that cell. So it's either 1, 7 or 3, 9 here. One of these is a 7. These -4 cannot contain a 3, 5, or 9. So 1, 5 is ruled out. It could be 2 and 6. So this could be 2 and 6. Cannot be 3 because there's no 3 allowed. Could be 4 and 8. So this would be 4 and this would be 8. And cannot be 5, 9. So those are the only possibilities, and they're both even. These have to be 2 even digits, so it's 2, 4, 6, 8. These are 2 odds. So this is either 2, 4, 4, 6, or 6, 8. If this is 2, 4, this cannot be 2 even numbers here. Actually, in fact, we know one of these is even, one of these is odd. And one of these is even, one of these is odd. So these both have to be odd. Right? Because we know these are 2 evens because we have 4 odds already here. So maybe we should be marking the odds and the evens because that seems to be actually very helpful. So this is even, these are odd. This is odd, this is odd, these are all evens. This is odd and these are all odd. These must be even. These must be even. One of these is even, one of these is odd. So this must be 2 odds. This is odd, obviously. This is even. This is even, this is odd. These are all odd. These must be even. This can't be 4, so this has to be specifically 4 and 6, which makes this an 8. So this is an 8. This cannot be 8. Where's the 8 here? It has to be here. Oh, and 8 can only be with 6 to make... So this is 4 then. 5, 4 could be with 1 or 9. Either one works. This can't be 6, so this must be 4. These can't be 4. Well, we can no longer have 1 here. If this were 1 and 3, that would have to be 6 here. Actually, that does work. And 6, 3 does not add up to -2 with -9. So this cannot be 9. So this has to be 1, 6, which makes this a 9. These are 2 odds. This is a 4. Let's see. This is either 5 or 9. So this is either 5 or 9 or 1 to add to get -4. So either way, the 5 has to be here, which means the 5 has to be here, which means this is a 5. So this can never be 5 here. So it's either 2, 4, okay, so 1 could be here. This cannot be. So 3 is one of these 2. Okay, not too helpful. If this is -4, it cannot contain a 4 or 6, so therefore it would be, if it's even, it's 2 and 8. And that does not work. So these has to be 2 odds, which means it cannot be 7. It could be 5, 1, can't be 7, 3, it could be 5, 9. So either way, there is a 5 here. So this is 5 with 1 or 9. This can't be 5, this can't be 5. So this can't be 5 here, so this must be a 2, which makes that a 5. This is an odd. This is an odd. Well, this must be an odd and an even, so this can't be even. Therefore, this must be odd. And this is the last odd, so this is 7 and 6 or 8. Well, this must be 2 and 4 added, so this can't be 3 here, because we know one of these 2 is a 3. This is 2 and 4, and it can only add up to 6. So this is 6. This has to be 7 and 8 here. So these are all even. Well, we have all the evens now. This is 2, 4, and 6. These then have to all be odd. So this is odd. This must contain an 8, because that's the only place for 8. So this is 8. This is 4. These can't be 4, so this must be a 2, 6 pair, which forces this to be a 4. So this is even, this is odd. Obviously, this is odd. One of these is odd, one of these is even, and one of them is an 8. We have an 8 with possibly 1, 3, or 9. So this cannot be 5. So this has to be a 5 here. Interesting. So this is odd, which means we need an even with it. It cannot be 8. It could be 2, 4, or 6 with 5. This can't be 4, though. So can it ever be 9? 5 and 4 add up to 9, so that works. Can this be 3? 3 and 5 only add up to 8, so that does not work. I guess it could be 2 and 3 with 5. That works. 1 and 5 add up to 6, so all of them still are valid. This is 8. It could be 3, 1, or 9. It cannot be 9, though, here. If this were 9, the 8 would be with it, and then you would not get -1, because 8 would be 8 in another digit has to add up to at least 9. So this can never be 9, which means in this row, 9 has to be one of these 3 cells. So this can never be 9. So this is 1 or 3. 8 can be with 1 and 6. 8 can also be with 3 or 4. And this has to have a 9 here. So this is a 9, which means the other 2 digits must add up to 7. So it's either 1, 6, 2, 5, or it cannot be 5, so this can't be 2. And it's or 3, 4. Well, the problem is, where's a 2? The 2 has to be here, which means this has to be 2 and 5. So this is 2 and 5. It comes with 3 to add up to 5, right? 2, 3, add up to 5. So this can't be 3. This is 1 or 9. This can't be 1. We have a 1, 5, 9 triplet here. So therefore this must be 3 and 8. Since this must be 3 and 8, well, this can't be 3. So this is 8. This is 3. This has to be 4 to get -1. So this cannot be 3 and 4. This now becomes 1, 6, and 9. Well, this can't be 5, so this must be a 2, which makes that a 5. This can't be 2, so this is 6, which makes that a 2. This can't be 6. This is an odd. This is an even. This can't be 2. This can't be 4. This can't be 2, so this is 7, which makes this a 2. This can no longer be 2, and this can't be 8. So this is 1, 4, or 6 here. 1 can only be 3 away from 4, so this has to be 1, 4, which makes this 6, which makes this 8. This cannot be 1, so this is 5 and 9. And we have the remaining digits are 2 and 7, so this is 2 and this is 7. This can't be 1 again, so this must be 9. This is 6, this is 1, which makes that 9, that makes that 1. This can't be 9, so this is 5 and 9. This can't be 5, so this is 4 and 5. This can't be 8, so this is 6, and this is 8. This can't be 4, so this is 1, which makes that a 4. This can't be 1, so this is 6, 1. This can't be 2, so this is 8, 2. This can no longer be 1, 7, so this has to be 3 and 9. This can't be 3, this has to be a 5. So this is 5, which makes this a 9. This can't be 9 anymore, so this must be 1. So this is either 4 or it's 6, but this must be 6 because this can't be 4. So this is 6. These 2 digits add up to 9 to give a 0. So it cannot be 1, 8, cannot be 3, 6, or 4, 5, so it's 2, 7. So this is 2, this is 7. These can't be 9. The remaining digits here are 1, 2, and 4. This cannot be 2 or 4, so this must be a 1, which means this is 2 and 4. And it must have another even digit, so this must be 8. So this must be 2, 4 here. This has to be a 7 remaining. This can't be 1. This can't be 1. We can remove that. This can't be 1 anymore. This can't be 4, so this is 6, which makes this a 4. This can't be 7, so this is 3, which makes that a 7. 1 and 7, so 7 is negative, so it has to be 1 and 5 here, which makes that 9, which makes that 3. That makes that 5, which makes that 9. This can't be 4, so this is 2, which makes that 4. This is a 3, and it has to have 1 and 6 here. Well, this can't be 8, so this is 7, this is 8. This can't be 3, so this is 9 and 3. That makes that a 1 and a 9. This is just normal Sudoku. This must be a 6, and this is a 1. Woo! That's some very interesting logic for the inverted killers. Yeah, I mean, I would look forward to any similar puzzles in the future. It's very, very unique, though. The only thing that really helped me from I've done a ton of Killer Cage Sudokus. So I'm very experienced with that. But the only thing that really helped me was basically figuring out the odd and even stuff here. Everything else was kind of, it didn't feel like I got anything from the Killer Cage from having been experienced with Killer Cage Sudokus. And basically, like, yeah, it was. This felt more like an odd even parody thing because trying to find which ones were even and odd helped a lot in basically deducing what could be what. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.